Hello and welcome to the 7th lecture of the ICS 103 programming course, and in this lecture we'll be basically talking about repetition structures, okay, or structures that can repeat and do the same task again and again. So first of all, we're going to be talking about repetition in programs, then counting loops, then we're going to be talking about while loops and for loops. Then we'll be introducing you to conditional loops, where the conditional loops are Sentinel control loop, nested loops, do while loop, flag control loop, and break and continue loop. Okay, so the break and continue statements actually which are inside the loop. So we'll be introducing you all into this. So repetition in a program, we actually have learned how to do coding, and where the program will go line by line in your code. So in your main program, your program is going to go line by line executing each code that you have written in it, or the commands that you have written in it. Okay, it is useful sometimes to have a code that will repeat itself. It'll go in round and repeat itself until a certain condition occurs. Okay, so writing out a solution to a specific case of problem can be helpful in preparing you to define an algorithm to solve the same problem in general. Okay, so this is a general comment. After you solve specific cases, you need to determine whether loops will be required in a general algorithm, and if so, then use one of the loops that we'll teach you in this class. Okay, so basically it is up to you as a programmer to decide whether you want loops or not. If you require loops, then please go ahead, use one. If you do not require loops, then do not use loops. Okay, so it is up to you as a programmer to determine whether loops are actually required or not. Okay, so let's talk about some basics over here. Loops. What are loops? Loops are a group of instructions. Computer executes repeatedly while some condition remains true. Okay, so you have a condition, so there is a condition. That condition, as long as that condition is true, you keep on repeating and repeating and repeating. So you write a block of code, so you write something between two curly brackets in C program, for example, and whatever you write in between this, you want the computer to repeat it until the condition becomes false, so you can actually determine that your loop has ended. Okay, so this is what is a loop. Okay, there are two types of loop. There's a loop that is called the counting loop, and it's a definite repetition. You know how many times you have to loop while you're executing. Okay, and you can have a control variable loop to count the repetition. Okay, so what does that mean? In examples, like when I ask you to write a program that prints for you the numbers from 1 to 10, okay, you know exactly how many times you have to print those, how many times you have to print a number. So you have to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many times do we have to loop? We have to loop in this 10 times. This is an example of a counting loop where you exactly know how many times you have to loop. Okay, so as soon as you count it 10 times, you have to stop your loop, and that is what we call the know how many times loop will execute. Okay, so this is what we mean by know how many times a loop was going to execute. Or you can have a control variable in which you can, inside the loop somewhere, define a variable and then initiate it with 0, for example, and then whenever you come to that loop, you can add 1 to it at the end of the loop and then check on the condition if this has actually reached 10 or not. So in our case, we will define, for this one, we will define an integer variable, let's say x, and then we will have some sort of loop. I'm not going to write the loop over here, but you will have some sort of condition here. Actually over here you can say x is equal to 0, and if x is less than 11, let's say, and you have to do, and this is how you write it, while x is less than 11, you do something over here, and then you say x equals to x plus 1. Okay, so you add 1 to x, okay, at the end of the loop, and you keep on looping over here. So you put a condition x less than 11, and then you actually are inside the loop going and incrementing x by 1, so that whenever you are looping, and the loop will occur between the two curly brackets, so any instruction between these, you'll keep on looping until this condition becomes false. So when you start, x is equal to 0, so this is true, so you go inside the loop and you conduct the loop, and then you increment x by 1, that will become 1, and then you come back over here, check if 1 is less than 11, that is true, so you keep on looping until you reach 10. 11. Is 10 less than 11? Yes, you keep on looping over here. Then you have some instructions here. Then you have x is equal to x plus 1, where then x will become 11 and x is less than or 11 and x is 11. This condition will become false, so you actually jump out of the loop and you continue your program from after the close of the curly bracket from the loop that you just exited. Okay, so this is basically a counting loop. So in a counting loop, basically you know how many times you want to loop. The only thing is that you have to just write it in a correct structure and then do the counting in it. Okay, there are conditional loops. Okay, so there are sometimes loops where you do not know how many times do you actually have to loop in your program. In that case, you use a conditional loop, and one of the most known is the Sentinel controlled repetition. Okay, what is a Sentinel controlled repetition? A Sentinel value is a value that usually you do not reach in your program. Okay, for example, if I wanted to enter the grades of students as an example, and you did not know how many students I have, you could ask me actually to enter a negative value to indicate that there are no more students, or the students list has finished. Okay, so suppose that we have a class instructor who has X number of students, and you actually ask him to enter the grade of students because you're doing something in the program. So you're going to ask him to enter the grade of student number 1, then student number 2, then student number 3, then student number 4, and you tell him, whenever you want to stop my program, give me a negative value. That will be a Sentinel value for you, the negative value. Why? Because the grade of students can never be negative. It's either 0 or it's a number greater than 0. Okay, so nobody will take out marks from you. The minimum mark that you can get in any class that you take is 0. Okay, so that is a Sentinel controlled loop repetition. You have indefinite repetition, so where you are looping for indefinite amount of time or for infinity. You can be used when the number of repetition is not known. The Sentinel value indicates the end of data. Okay, so any Sentinel value basically indicates that data has ended, just like the negative number for the grades of students. Okay, so these are all examples, and I'm going to go in details in each one of them. Okay, so let's look at our flow chart of how our program actually works. Inside the main, or in any C program actually, or any programming language, you usually go executing the statements that you have sequentially, one instruction after the other. And then when you are designing your algorithm, the first question that you have to take and have to understand is, are there any steps that need repeating? Okay, so when you're solving your problem, you have a problem, you want to solve it, you just ask yourself this question: is there something that I need to repeat? If there is nothing that I need to repeat, don't use loops. Okay, you don't need loops. Go ahead, use our sequential programming, and that's it. You'll finish your program. If you need something to be repeated, then you have to ask your question: do you know how many times I have to repeat this thing? Okay, if you know how many times you have to repeat this thing, use a counting loop. Otherwise, use one of the other loops, Sentinel control loops, or end of file control loop, or input validation, or any other type that you can actually imagine. Okay, so this is basically telling you how to determine if you want to use loops or not. Okay, so basically you ask yourself the question: are there any steps that are repeated? If the answer is yes, then you ask yourself the second question, say, do you know how many times do I have to repeat? Okay, and I'll have examples coming in a while on this. Okay, so counting loops. So the example shown below is a pseudocode. It's called a counter control loop, or counting loop, because its repetition is managed by a loop control variable whose value represents the count. Okay, so what do you do in this pseudocode? The first line is you set up the control variables to an initial value of 0. Actually, you set up the control variable to initial value, and that value should be the identity of the operation that you are using. If you are using a multiplication operation, then set it for the identity of the multiplication, that is 1. If you are using a counting loop, the counting for counting, it's addition, the identity of addition is 0. That is why we say set the loop counter variable to initial value of 0. Okay, for any counting loop, you'll set it to 0 actually. And then you have the while, and you say that this value, which is the control variable, is less than the final value. So you know how many times you have to loop in this example. You say if this value is less than the final value, you do something, and then you increment the value by 1. Okay, so the example, a typical example would be if I had 10 students and I wanted to add their grade. I will go and I set the number of students to 0. Then I'll say while my number of students is less than 10, I do something over here and I add the number of students to a variable that I declare, then I increment the number of students by 1. Because I have already taken 1, I'm going to increment it by 1 and then go ahead again and then do something with the second value that the second student's grade, then increment the value again and still do it until I reach 10 students. And when I reach 10 students, this condition will become false, so it'll jump out of the loop. Okay, so we use control loops when we can determine prior to the loop execution exactly how many loop repetition will be needed. Okay, if you do not know how many repetitions are needed, then you are not looking at counting loop, you are looking at other types of loop. Okay, you only use the counting loop for repetitions that you exactly know how many times you have to count. Okay, this is an example, very easy example. This is a program fragment that computes and displays the gross pay of 7 employees. Okay, so if I have a company where I have 7 employees, I can actually make this program to calculate how much they are paying. Okay, let's start. The loop repetition condition controls the variable loop, so we'll talk about the loop repetition condition. So we declare a variable of count temp as integer. This is something that I did not show you over here, but suppose that this is an integer and I set the value before the loop to a 0. This is the first step you actually do. You set the control or the repetition condition loop variable to 0 or to the identity of the operation that you're using. Okay, in our case, it's a control loop that is basically for counting, and for counting we use addition, so the identity is 0. And we say while count is less than 7. Okay, so we actually count employee. So if I have a count employee are less than 7, that means I did not finish processing all the 7 employees. So I do a repetition. What do I repeat? I repeat everything that is between the 2 curly brackets. Okay, so whatever is here, I'm going to repeat it until this condition becomes a false. Okay, so my count employee is equal to 0, and I check if 0 is less than 7. That becomes a true, so I go inside of my loop. Okay, so this is the loop repetition condition. And in here, I'm going to print for the user hours, and then I'm going to ask him to enter the hour. Okay, then I'm going to be prompting the user to enter the rate of that person, and then I'm going to be reading that to the variable rate, and then I'm going to be calculating his pay, which is the hours multiplied by the rate. That is going to be his pay, and then I print to the user the pay, and then I increment my employee by 1 because I finished processing the first employee. Now I'm going to the second employee. So here's how the program is going to go. It's going to come and set the count employee to 0. Then it's going to check, is count employee less than 7? Yes. So I'm going to put over here count employee just for the sake of giving an example. So the count employee is going to be 0. And then you compare 0 to less than 7. Yes, 0 is less than 7. So you go print this, you calculate the pay, and then you say count employees or count employee plus 1. That means go to the count employee. What's the value of count employee? The count employee is 0. You add to it 1, it becomes 1. And I want you to assign the value of count to the variable count employee. So anything that was in it will be lost. So 0 will be lost, and you'll have a new value of 1. Then you come back over here and check, is count employee less than 7? What's the value of count employee? 1. Is it less than 7? Yes, it is less than 7. So I'm going to go and print this again for the user, calculate the pay, and print the pay. And then I'm going to say count employee is count employee plus 1. So 1 is going to be lost, and I'm going to have 2. And then I'm going to come back to the condition, check the condition. Is the condition true? Yes, it is true. The count employee is 2. 2 is less than 7. So I'm going to go, and I'm going to be repeating this for 2, 3, 4, 5, 6. And then I'm going to come to the 6th person, take the hours, calculate the rate, take the rate, calculate the pay, and then print the pay. And then I'm going to increment my number by 1, so I'll have a 7. So I'm going to go 7 is less than 7. No, that condition is false. So my compiler or my program is going to jump from here and start from this line of code. So it will start from exactly after the curly bracket of the loop that I am in. Okay, and then it will print all employees have processed. I finished all processing employees. It will be printed to the user. I had 7 people in my company, and I have calculated their pay based on their hour rate and the hours they have worked and the rate per hour that I have agreed with them. Okay, so this is how counting loop works. Okay, so in this case, I knew that I have 7 employees. That's why I set in the while loop that the employee count is less than 7. Okay, so while statement. Generally in a while statement, what do you have? You have the while keyword. You have to write it while. It's It's not capital, it's small actually. So this is a small w, not a capital W. A while and the loop repetition condition between brackets. So you write the condition for which you want the program to actually be looping until this condition becomes a false. Okay, so you write the condition between two brackets. Do not forget the two brackets. And then afterwards you have the curly brackets. And the curly bracket indicates that you have to repeat all the statements that are between these two curly brackets until this condition becomes false. Okay, if it doesn't become false, you have to continue and do the conditions that you have to do. Okay, so first of all, to do any while loop, you have to do an initialization of the variable, the condition. So we said in our last example, we said count employees equal to 0, and we usually do the initialization of the variable outside the while loop, and we only do it once. So it comes to that, initialize it, and then the while loop, it goes repeat this again and again and again and again and again and again until this condition becomes false and comes out. Okay, so you do the count employee equals to 0, you do the initialization. This is called the initialization. You do it outside the while loop. Okay, then you do a test. What do? We hit the count employee less than 7. This is the example of a test. This is where you test if you have to go inside the loop or not. If this condition becomes a true, you're going to inside the loop. If this condition is false, you're going to jump and continue from here. Okay, then there is the update, and this is the update over here. Okay, count employee equals to count employee plus 1. This is the update where I'm actually incrementing the counter by 1 so that I know how many employees I have processed. Okay, so you do the update, then check the condition again. If that is true, you come back in. You do the update, you check the condition again. If that is true, you come back in. You do the update, you check the condition again. If that's not true, you get out. Okay, so you keep on doing this, and this is how loops in computer work. Okay. The above steps must be followed for every while loop. If any of these skipped, it may produce in an infinite loop. What is an infinite loop? Is a loop that the computer can never get out of. Okay, for example, if I forget to put this line in, okay, so I am calculating the pay and I forgot to do the increment, my count employee was never going to increase at the end of the loop, so it's going to stay at 0. So I'm telling the computer I'm still at employee number 0, and he's going to keep asking me on employee number 0, keep asking, and he's never going to get out of this loop. Okay, now notice one thing: the initialization is outside the while loop, while the condition are between the brackets, and the increment is in between the curly brackets of the while loop. Okay, so you have to write it somewhere in between. You have to write the condition. Okay, so that's about it for this slide. So I'm going to move to the next slide, and in the next slide we have the example count employee grade less than 7, but we may have more than 7 employees. Okay, so if we had more than 7 employees, our program is not going to work because we have to go change the source code and put the number of employees and then recompile it and then bring an executable so that the person who is using the program can actually run it. Okay, to make our program fragment more general, we should use a printf scanf to get the number of employees and store it in num of employee. Okay, so we define a variable num employee, and we ask the user, if we ask the user in the beginning, enter the number of employee. Okay, so the user is going to enter it, and we're going to save it into this variable. Then we can actually check if my count employee is less than the number of employee. That will make it go to n number of employees, where the user has actually entered how many employees he or she has. Okay, so the number of employees he or she has will be stored over here, and then you start from 0 and say, okay, I know I have not, if the user entered, for example, 20, I know I'm starting at count employee to be 0 in my program, and then I increment my count employee 1, 2, 3, 4, and I go on until 20, and then I exit my loop because this condition will not be true. Okay, so this is how you generalize your program. Okay, you take the number of employee from the user, and you ask the program to actually run until your count employee is less than the number of employees, so you cover all the employees that you have in your organization. Okay, another very typical example that we actually use is the sum of I from I equals to 1 to I 100. So I want to write a program that does this for me. Okay, in this I know how many times I have to loop. This is again a counting loop. Why? Because I know that I is from 1 to 100. That means I'm counting 100 times. The sum of I is equal to 1 plus 2 plus 3 plus 4 plus 5 until plus 88, 98, 99, and 100. Okay, so this is the sum that we are actually targeting to actually calculate. To do this, this is a complete program, so we define our directives, and in the int main void we define our variable sum and I. Okay, we initialize the variable of sum to 0. Sum is the variable where we intend to store the addition of all of these numbers. Okay, and I is just a variable which is I'm using as a counter. Okay, so why did I initialize sum to 0? I initialized sum to 0 because the operation that I'm using is an addition, and in the addition operation the identity of it is 0, the value is 0, so I put my sum to be 0 so that when I ever add anything to it, to the sum over here, so I have the sum variable, whenever I add something to it, when I started with the identity variable, it will not affect my program. Okay, so I started with 0. Why did I start I with 1? Because the question asks me to start I from 1 to I till 100. Okay, so I start from I is equal to 1, and I say while I is less than or equal to 100. What does this mean? I'm asking the computer to check if I is less, if the value of I is less than or equal to 100. That means that the value of, if that is true, I'm going to go inside my loop, otherwise I'm going to go out. So in the first one I was 1, so this will become true, 1 is less than or equal to 100. Then I go and add to the sum the value of I, so I add the first number I, and then I say I is equal to I plus 1. I increment I by 1, it becomes 2. Okay, so if I just put the value of I over here, and it will be 1, then when I come over here, this is going to be lost, it's going to become 2. Then I'm going to go over here, is 2 less than or equal to 100? Yes. I say sum is equal to sum plus I. Now in the sum I already added the 1, so I put sum over here. So the sum had the value of 1, because I added the sum. So it has a 0, this was initialized by 0, so this is the 0 that was initialized with, and then I added I into it in the first round, so I was 1 and I added 1 to it. And then I incremented I by 1, it became 2. So I'm going to go now and check if 2 is less than 100. Yes, it is. So sum is equal to sum plus I, so I'm going to add I, which is 2, into it. Okay, and then I'm going to come and say, okay, forget the old I and increment I by 1, that will become 3. Then I can, 3 is less than 100. Yes, so I'm going to go add 3 into it, and then increment I by 1 is going to become 4. Then I'm going to add 4 into it, increment I by 1 is going to become 5. Then I'm going to add 5 over here, and so on, going on this way. This will reach 99, so I'm going to add a 99 over here. Then I'm going to increment I by 1, it's going to become 100. So is 100 less than or equal to 100? Yes, it is true. So I'm going to go sum is equal to sum plus I. So I'm going to add the 100 here, and then I is equal to I plus 1, so I'm going to add 101 over here, and then I'll come back over here. Is I less than or equal to 100? And 101 is not less than or equal to 100. That means that I have reached false condition, and in that case I will jump out of my for loop and I'll print the sum is, and I'm going to print the value of the sum, which is from 0 to 100, exactly what I wanted to print. And then I'm going to stop my program. Okay, so this is actually how you use while loops in actually counting loops, and you actually solve a problem. So we solve the problem of adding numbers from 1 to 100. So we add from 1 to 100. We initialize our variable by 0 because it is the identity. So we add the value from 1 to 100 to the sum, and we actually had a counter I, a value that was incrementing into the loop, so that we can actually know how many times we looped, and we used it in the same manner to do the addition because we want to add I to the variable sum. Okay. Okay, so we've seen this expression several times in our program. X is equal to x plus I. So that means that take the value of x, add to it I, and then the new value assign it back to x. And eventually it means increment the value of x by I. Okay, this is what this statement actually means. Now, in C, what they started doing is, instead of doing and writing this like this, they came up with this way. So write x plus equal to I, and this is actually equivalent to writing x equals to x plus I. Okay, so you write it this way or you write it this way. These are all the same meaning. When I say x plus equal to I mean add to x the value of I. Okay, and we write it x plus equal to I. So the compiler is going to understand this. There's no problem in this. And then x is equal to x plus I. This is also something that the compiler actually understands. That means take the value of x, add I to it, and assign it to x. But this is easier to write, so in C they actually use it more often than this. Okay, so we use this more often than this in C. You can use minus equal to, multiply equal to, divide equal to, and percentage equal to. And what we'll do is it'll subtract the value of I from x. If that use minus equal to, if multiply equals to, you're going to multiply the value of x by I. If divide equals to, you're going to divide x by I and equate it. And if you do modulus to, remainder operation, then you'll take x remainder I and put it into x. Okay, in the same way you can expand it to all of the operations that we have learned till now. Okay, so now comes the prefix plus plus x and the postfix x plus plus. Okay, both of them are used for incrementing a value. Okay, so if you put plus plus x and x plus plus, this is will give you the same result as x is equal to x plus equal to 1, or equivalently saying x equal to x plus 1. Okay, so this is exactly the same, and this is equivalent to saying x is equal to x minus 1. Okay, so you can actually put minus minus x or x minus minus, the same value as x minus 1 equal to. So the values of these two are equivalent. However, the result of this and the result of this are similar, but there is a big difference in how you come from here to here. If you use plus plus x, or you use x plus plus, or you use minus minus x, or use x minus minus, there is a big difference in doing the operation. Okay, the value of the expression in which plus plus operator is used depends on the positive of the position of the operation. Okay, so if x plus plus, this is the operation, the plus plus, if it's put on the right hand side, it has a different meaning than when you put it onto the left hand side. Okay, when the plus plus operator is placed immediately in front of its operand, prefix, so it's before it, okay, the value of the expression is the variable after the increment. So you use the value of the expression after incrementing the variable. Okay, so when you have x and you put plus plus in front of it, what do is you increment x, then use it in your expression. Okay, if you have x plus plus, use the value of x in the expression, then increment x. Okay, so there is a difference. Here you increment first, then use it in an expression. Over here you increment after you finish the expression. Okay, so first you do the expression, and then you do the increment. Okay, so here is an example. So suppose I have I as a variable and I have 2 in it, and then I declare another variable j as an integer, and I don't assign a value in it, so the value in it isn't a random value or a value that is unknown. Okay, a garbage value. Okay, then I do an increment of x, and in the first example over here, there are 2 examples over here. In the first example I say plus plus I, and the second example I say I plus plus. Okay, now when I say plus plus I, this is equivalent to actually saying that since I have the plus plus on the left hand side, I say I is equal to I plus 1, and then j is equal to I. Okay, so this means these 2 operations. I have to increment I first because the plus plus is on the left, and then I do the assignment operation or whatever expression that I have over here. I use the value of I after I incremented it. Okay, whereas on the other hand, if the plus plus was on the right, this is equivalent to saying j is equal to I, and then I is equal to I plus 1. Okay, so you see the difference. If I say j is equal to j plus plus I, you do the I equals to I plus 1, then j is equal to I. If I say j is equal to I plus 1, then you go j is equal to I, and then you increment I by 1. So the increment is before then the assignment in the case where you have the the plus plus on the left, if you have the plus plus on the right, the assignment is first and then the increment. Okay, so the expression is first, then the increment, and over here the increment is first, then the expression. Okay, so in this case, if I was 2 and you use this, using this analogy, you will say you will increment I by 1, so I is equal to I plus 1 to become 3, and then you say, so I will become 3, and then you'll say j is equal to I is 3, so use j is 3. Whereas in this example, what you're going to do is going to say j is equal to I. So what is the value of I? The value of I was 2. So I'm going to assign j value of 2. Then I'm going to say I is equal to I plus 1. And I'm going to increment my I by 3. So at the end of the statement, both of them result with 2 different values. Although the value of I is the same, the value of j is different. That is because the assignment operation, is it prior to actually incrementing the number or after doing the expression? Okay, so if you want to do it before the expression is conducted, put the plus plus on the left hand side. If you want to do it after the expression is conducted, put the plus plus on the right hand side. Okay, here's another example. In this example, suppose that we have n is equal to 4. Okay, so now we have n is equal to 4. The example is, what will be the output of the following code? Printf percentage 3d minus minus n. Then we have a printf percentage 3d n. Now the 3 and the 3 over here means the 3 spaces and 3 spaces, and I'm going to be printing only one number, so I'm leaving a space between them, that's all. So when I come to over here, now I have the n for this example. I'm going to draw a line here. So I'm going to just write over here, my n is equal to 4. Okay, so this is my value of n. And then I'm asking you to printf percentage 3d minus minus n. What does minus minus n mean? Since this is on the left hand side, it means decrement the value of n by 1, then do the expression. So I'm going to say now, okay, so n minus n means that 4 will become 3, and then I'm going to go and print the 3 using a 3d, so I'm going to be printing this for you. Okay, so this is the first line. And on the second line, there's a printf 3d, and I'm going to print value of n. The value of n is 3, so I'm going to be printing this for you. Okay. On the other hand, over here, if you have the example is n is equal to 4, this is what I start with, and then I say printf percentage 3d n minus minus. So I ask you to print first and then decrement the n by 1. Okay. So I decrement the n later on, so I print the number first. So I'm going to be printing space 4 because I have the 3 over here, and then I have a printf n, and after I printed this 4, I'm going to go decrement the n by 1, so it's going to become 3. Then I print the n, and the n is going to become a 3. Okay, so I print space 3 over here, and this is due to the fact that the n minus minus is equivalent to saying n in the first statement, and the second statement n equals to n minus 1. And over here, what is equivalent to is, this is n is equal to n minus 1, then it's equivalent to saying print n. Okay, so print n, and you decrement n first, then print n. In this case, you print n and then you decrement n by 1. Okay, and this is the difference between the plus plus and the minus minus. Okay, be careful when you are in your exams or when you're writing C code that you do not misplace the minus minus. Make sure that you know where you're putting it. Is it before the variable or after the variable, to make sure that there is no difference in your calculations. Okay, the better way to construct loop is to use a for statement. Okay, now we're shifting to a for. We talked about the while loop. Now we're going to be talking about a for loop. In a for loop is a more structured way of writing a loop. Okay, as before in the loop with the while, we'll have to initialize, test, and update. An important feature of the for statement in C is that it supplies a designated place. There's a designated place. There's a special place. There is a single and only one place for each of these 3 components. So for the initialization, for the test and update, there's one place that you can put it. Whereas in the while, you can initialize anywhere before the while. The condition or the test has to be between the brackets after the while, and the update could be anywhere between the 2 curly brackets. Whereas in the for, there are specific places for each one where you have to put it. Okay, so the example of a for loop that I'm going to show you is this one, and in this one is I want to compute the sum from 1 to 100, and I say integer sum is equal to 0. This is my initialization. So I initialize to 0 because I'm going to do a sum, and the sum is from 1 to 10, and I initialize it by 0 because 0 is the identity of the sum. And then I declare a variable int counter, so I'm gonna go into the memory and reserve a place for counter. Now I say for, and this is how I write my for loop. I say for, and between brackets I put the initialization, then I put the condition or the test, and then I put the update. Okay, and this is how it's written. They are always followed by semicolons. So I say counter is equal to 1, counter less than or equal to 10, plus counter. Okay, what am I telling the compiler? I'm telling the compiler, hey, start with a counter, initialize it by 1. So this is the initialization. Okay, so control variable name, this is counter, and this is the initialization value of the variables, counter from 1. So I'm asking it to assign the value of 1 to counter. Okay, so so the value of 1 is going to go inside counter. Then it's going to check the condition, counter less than or equal to 10. Is counter less than or equal to 10? 1 is counter, so is it less than or equal to 10? Yes, it is. So I'm going to go inside my loop, conduct my loop, and then I'm going to come back around here and do the increment. Okay, so here is how the loop is working. Before the loop, you come in a sequential manner. As soon as you hit a 4, this is the first operation that you do, and this is usually an assignment operation. It's just like counter equals to 1, or you can have a scanf, where you can have a scanf and the percentage d, the address of counter for the user to input an initial value, or you can have any other type of initialization method that you like. Okay, so this is the initialization. So the compiler comes over here. The first thing it does, it performs the operation that is written over here. Then you have a semicolon. Then the second thing it does, it actually tests this variable or the test case that you have over here. In our case, counter is less than or equal to 10. What is the value of counter? We started with 1, so it's going to check 1 is less than or equal to 10. Yes, it is. Then what's going to do is going to jump and conduct whatever is between, this is 3, is going to conduct whatever is between the two curly brackets. So sum is equal to sum plus counter. Sum was 0, so I'm going to add the value of counter in it. So I'm going to add 1 to the sum. When I finish my for loop, I come back, and this is the fourth operation I do. I increment, I have an expression over here. I have to evaluate it to know how much I have to increment my value. So the counter is going to be incremented by 1 over here. I have plus counter. So I'm going to increment the value of counter. It was 1, it will become 2. Then what I'm going to do, I'm going to go back to step number 2, and I'm going to check counter less than or equal to 10. Is 2 less than or equal to 10? Yes. So I'm going to go back over here. From here, I'm going to go to 3. From 3, I'm going to go to 4. Okay? So this is how it goes. It goes from here, it jumps over here. This is 1, 2. So it goes 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, and that's the loop that you have. So you only initialize once at the beginning, and then you loop over here. Okay, so this is how the program flow actually goes. Okay, so you increment the counter, it became 2. Is 2 less than 10? Yes, I'm going to add 2. Then I'm going to increment counter, it's going to come 3. Then I'm going to add 3 over here. Is 3 less than 10? Yes, I'm going to I'm going to conduct over here, then increment 3 to 4. Is 4 less than 10? Yes, I'm going to add 4 to the sum. Then I'm going to increment, it's going to become 5. Is 5 less than 10? Yes, I'm going to go inside and put 5 inside the sum. And then I'm going to increment 6 and 7 and 8 and 9 and 10. And then when I finish the 10, it becomes 11. I go to the test, and the test tells me that 11 is not less than or equal to 10. So I jump out from here to the end of the curly bracket, and I continue my program from here. Okay, so this is how the for loop is actually going. Okay, and it keeps on looping from steps 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4 until condition 2 is false. And when the condition is false, you're going to get out of the loop. Okay, so 4 is a keyword. This is the control variable. This is the initial value that's going to start with. The initial value usually is either given to you in the question or the identity of the operation that you're using. Okay, then you have over here is the loop control condition. So this is the condition where you put it, and this is the increment. Okay, now I'm going to do a thing over here, and I'm comparing this to the while loop that I showed you about 5 minutes ago. Okay, so here's a while loop. Okay, so this example, I'm gonna put it this way. Hopefully you guys can see it. Okay, so you guys can't see it, so I'm gonna put it this way. Okay, so you remember this example. The example basically was to add from 1 to 100. Okay, so the difference, if we make this example add from 1 to 10, it will be the same example that is over here. Okay, so to write this program, notice what I did over here. Over here I initialized my I to be 1. Okay, my initialized I to be 1. Over here I initialized my counter to be 1. Okay, it's the same program, but I'm just using different variable names. Here I used I, here I'm using counter. So I initialize value of I to be 1 and counter here to be 1, and then inside the while, between the two brackets, I actually checked if I is less than or equal to 10 or 100, whatever the value was, and over here I put the semicolon and put the condition. So see, this is the initialization condition, and this is the update. I is equal to I plus 1. Over here I just put it counter plus plus or plus plus counter, okay, which is equivalent to saying counter equals to counter plus 1. Okay, so I do the condition over here. So notice initialization outside the while, condition in the brackets, okay, of the while, and between the curly brackets I do the update, whereas in the for loop I do the initialization as the first. Okay, I do the initialization as first over here, the test over here, and the increment over here. Okay, so this is a more structured loop. So this is just a comparison between the while loop and the for loop. Okay, now a fact is that you can write any while loop using a for loop and any for loop using a while loop. Okay, so there is no actual preference on which loop that you actually use. It is up to you to decide which loop you want to use, and this is an iteration again of what I said. If you use a for loop, you'll have the initialize, semicolon test, semicolon update, and this is what you put between the brackets. If you initialize and the test passes, you're going to go inside the for loop, conduct the steps that you have, then do the update, then do a test. If the test passes, you're going to go inside, do the update, do the test. If pass, if it's true, you go inside, you update, you test. If it's true, you go inside, you update. Then if this test becomes false, you jump out of the for loop. Okay, notice that there are no semicolons after the for loop. Okay, the same thing goes for the while. In the while condition, you don't put a semicolon at the end of the while condition. Okay, for clarity, it can be useful to place each expression of for heading on a separate line. Okay, so some people like to do this. I personally don't prefer this, but you can actually do it. You can put each one of them in a separate line. So you have an initialization on line, the test on the line, and the increment on a third line. Okay, if all the three expressions are very short, we will place them together in one line like we did in the last example. The body of the for loop is intended just as the if statement. Okay, so you indent the body of the for loop as just like the if statement. That's by putting a tab in the front, so you actually tell the person who's looking if you have a for loop and that these are the things that are inside it. Okay, now we move to conditional loops. We've talked a lot about counting loops. Now let's talk about conditional loop. In many program situations, we will not be able to determine the exact number of loops repetition we require in a program. Okay, and that's most oftenly the problem that we face. Okay, an example of this is we need to write a program that prompts the user for a value. So I want the user to give me a value and multiply it by the value of the variable temp. Okay, so I want to keep multiplying the values that the user is giving me. So the user is going to give me his first number, then the second number, then the third number, then the fourth number, and he's going to be constantly giving me numbers. It then stores the value in temp. Okay, so you multiply the value in temp and stores it in it. It keeps doing this until the user enters a 0. Okay, as soon as the user enters a 0, you're going to stop your program. Now, how am I going to do that? I don't know how many times the user is going to enter numbers. I cannot do a counting loop. Okay, so in this case you have to revert to a Sentinel controlled loop. Okay, so the algorithm basically is you take a variable temp and assign it the value of 1. Why did we assign it the value of 1? Remember, we always initialize it or we assign it the value of the identity of the operation that we're using. Multiplication has the identity 1, so we assign the value 1 over here. Okay, then we prompt the user to enter a value. And then we check, is this value equal to 0? If the user has entered a 0, that means he wants us to stop. So we jump out of our while loop and we actually print the value of temp for him. Okay, if he entered any other number that is not 0, we have to multiply that number to the number that was already stored in temp. So we're going to assign temp the value of temp times the value. So we multiply temp value and store it in temp. And then prompt the user for another value. Okay, so the user is going to ask me for, I'm going to ask the user to give me the second number. So I'll take the second number, and if that number is not 0, I'm going to multiply it by the value of temp, and then ask him for the third number, and the fourth number, and the fifth number, until the user enters a 0. As soon as he enters 0, I'm going to go out, and I'm going to actually print the value of temp for him. Okay, so here's how the program is basically written. So you say temp is equal to 1, so temp is a variable that you already declared, and you assign it the value of 1. We initialize it by 1 because it is the identity of the operation that we are using. Then you say printf, enter a value, so you enter a value. 0 will stop the program. This is what you tell the user. This is how you prompt him. You tell him 0, this is your Sentinel value that is going to stop your program. Okay, so the user is going to start entering a value, and then you scanf and %d and the address of value. So you read the value that the user entered and store it into the value variable. Okay, then you say while value is not equal to 0, if this is not equal to 0, temp is equal to temp multiplied by value. Okay, after you do this, you have to prompt the user to enter the second number and do a scanf to take the number from the user again. Okay, and you give him the same message as over here. So this is the initialization, this is the update. Notice over here we only update the value variable, not the temp variable where we're actually storing all our numbers. Okay, so we actually do this multiplication again and again, and we ask the user to enter a number, as the user is going to enter another number, and then we multiply it, third number, fourth number, until the user enters a 0. Over here, I do not know how many numbers the user is going to enter, but I'm going to be waiting for a 0. That's my Sentinel value to tell me that you get out. As soon as the user enters 0, this condition will become false, and then I jump out and I actually can print the value of the multiplication that I have already calculated in the variable temp. Okay? It is very common for loops to have identical initialization and update steps while performing input operations where the number of input values is not known in advance. Okay, so it is very common that you will be copying these two lines over here directly if you are taking an input from a user. Okay, Sentinel control loops. Many programs with loops input one or more additional data item each time the loop body is repeated. Okay, so there is an additional item that you actually count. Often we do not know how many data items the loop should process when it becomes execution. Okay, so most of the time you don't know how many times you have to loop in a program. We must find some way to signal the program to stop. Okay, so we want to tell the program, I'm going to give you a signal to stop, and that signal is called a Sentinel. One of the ways to give a signal is use a Sentinel value. Okay, the loop repeats condition test each data item and causes the loop exit when the Sentinel value is read. Okay, so whenever you reach or you find that you found the Sentinel value, you stop your loop. That's what it means. This is what we did in the previous example. We used 0 as a Sentinel. Okay, we told the user to input numbers. Whenever he enters a 0, that's the Sentinel value. We'll say, okay, we've finished, that's it, we're going to get out of our program. Okay, the Sentinel value should be a value that you never actually will use in your operations. Okay, just like in the multiplication operation, if I enter a single 0 into the operation, all the numbers that I multiply in the future with the value of temp in the last example will result in a 0 value. So that is a good Sentinel value for me. Okay, now here's another example of a Sentinel controlled while loop, and in this example I want to compute the sum of list of an exam score. So I have a list of exam scores and I have the student's name in them, and I would like to know how much is the sum. Okay, so to do the sum, I know that I have to enter the score of students. Okay, so I'm going to ask the person to enter a score of the students. Now I do not know how many students that this person has, so I'm going to be defining a Sentinel value of -99. Okay, you can actually define a Sentinel value anything, okay, that is not reachable. In our example, exam scores, the exam scores are usually from 0 to 100. It could be from 0 to 1000, it could be from 0 to 500, but usually there is no minus sign in an exam. Okay, so you cannot get -5 in an exam. What does that mean? It doesn't make sense. Okay, so I can use any negative value as my Sentinel. I have chosen over here -99 as the value that I'm using in my program. So I hash define Sentinel to be -99, so I define a constant Sentinel, I call it, and I say it -99. And here's how we'll use it. In the main function, we have int sum equals to 0 and score. So sum is the variable where I'm going to store the value of the scores of all the students. I'm going to add them up. That's why I initialize them by 0, and I declare the integer variable as scores. Okay. Then I prompt the user to input the first score, or %d, which is referring to the Sentinel, to quit, or -99 to quit. That's what's going to be printed to the user. So enter the first score or -99 to quit. So the user is going to enter a number. I'm going to read that number and store it into the variable scores. Okay, so I use the scanf %d address of scores. And then I say, while the score is not equal to the Sentinel, and this is my while loop where I'm going to be repeating again and again and again. I actually initialize the scores by a scanf, so I'm taking input from a user, and I'm actually saying over here, if this is not equal to the Sentinel, which is -99, I want you to add the sum to the score. So add the score to the sum. Sum is plus equal to score, so take the value of score and put in the sum. So this value that the user has entered, I want you to add it to the sum, and the sum had 0, which is the identity of the operation. So in the first loop, I'm going to have the score inside the sum, and then I'm going to ask the user to enter another number, and I'm going to read that number from the user. If the user enters another number, then I'm going to come back over here and check if he entered a Sentinel. If he did not enter a Sentinel, I'm going to take the score and add it to the sum. So this is the second student, and then I am asking for another score. Then I add the score to the third student, and then the user is going to go from his list until he exhausts it and he finishes all the students. When he finishes all the students, what he will do, he will look at this and say press 99 to quit. He's going to press -99 and enter. So you're going to read -99 to score. You're going to come into the condition and test. Is score not equal to the Sentinel? -9 is not equal to -99. That is not correct. So I'm going to jump out of my loop, and I'm going to say the sum of the exam is, I'm going to print the value of sum, and then I finish my program. Okay, so this is how I actually did a program where I actually asked the user to enter a number of students, which I don't know how many students are there. He can have 5, he can have 10, he can have 50, 1,000, I don't care. But when I told him to stop your program, you enter a Sentinel value of -99. I chose -99. You could have chosen -10, -5, -50, -100. It depends on your choice. Okay, but usually the Sentinel value is a value that you never ever reach in your calculations. Okay, or it's a value that cannot occur in logic. Okay, in real life logic. So Sentinel control loop, because of the for statement, combines the initialization, test, and update in one place. Some programmers prefer to use it in a Sentinel control loop. Okay, so over here, if I come back over here, so I have my initialization. This is my initialization, so I'll refer to this as initialization. And this is my test, and this is my update. Okay, actually the printf is only prompting the user, but the actual update is actually occurring over here. Okay, so when I want to translate this while loop into a for loop, here's what I have to do. I'll say, before the for loop, I'll say printf enter the first score, or -99, or the Sentinel value actually to quit. So Sentinel is -99. Then I come over here and say for. Now the for takes 3 things. The first thing it takes is the initialization, the second is the condition, and the third is the update. So what is the initialization? Is the scanf, and you're actually doing it over here. Oh, sorry. This is not the test. The test is this one, and this is the initialization. This is the initialization of the sum, but not the initialization of the variable. Okay, so this is not correct. This is the initialization to 0. It's correct. This is for the sum, but we are more concerned over here of the initialization of the while loop. So the initialization of the while loop occurs in the scanf, and then the test is this, and this is the update. Okay, so the same thing over here in the for loop. I do a scanf for the initialization, which is this one. Sorry, I do a scanf, and this is the initialization scanf, which is this one, and then I do a check, or the test, the score is not equal to Sentinel, which is this one over here, and then at the end I come and say scanf again to do an update, and I do the update, and notice inside I only put the sum plus equal to the score because I don't have to do the update. The update is outside, and of the body of the for loop, it's inside the brackets of the for loop, so that's why I don't have this line, and I put the printf, so just I prompt the user every time I ask him. Okay, so this for loop actually is equivalent to this while loop, okay, where I have to do initialization, test, and update. Initialization, test, and update. Okay, because it was too long, I put it in 3 different lines over here. Okay, so Let's talk about nested loops. Okay, nested loops. What are nested loops? Nested loops are loops that are inside a loop. Okay, so nested loops consist of an outer loop with one or more inner loops. Okay, so you can have as many inner loops as you like. So you have a bigger loop, and inside it you have a smaller loop, and maybe inside you have a smaller loop, and you can go on to infinity on this. Okay, each time the outer loop is repeated, the inner loops are re-entered. So in the outer loop, when you do it, you actually go into the inner loop. Okay, I usually tell my students that a loop, what is a loop? Loop is a way you come in your structure programming and then you start doing a loop. And this is how you do a loop. So you have some statements over here, you loop until the condition becomes false, then you get out of your loop, and then you continue your program normally. In a nested loop, what occurs is you come and then you have your loop, so you start doing a loop, and inside the loop you found yourself in another for loop. So actually you go and do the loops until the condition becomes false, and you continue your loop, and then you come back and you do your loop, and then you do the inner loop again, and then you continue, you come back, you do a loop, and then the inner loop that you do, and then you come back and you do a loop until the condition is false and you get out. Okay, so the loop is actually looping onto the statements that are over here. Then in an inner loop, you're going to loop onto the statement, but whenever you have an inner loop, you're going to loop it first. Okay, so it's a loop inside a loop. Okay, so each time an outer loop gets into the loop, you have to do the inner loop. Next time you get in, you have to do the inner loop. Then next time you get in, you have to do the inner loop, and so on. Okay, their loop controlled expressions are re-evaluated every time. All required iterations are performed again, so everything that you require in iterations are performed again. Usually we use it to work with two-dimensional arrays. We will discuss this later. Okay, now here's an example of a for loop inside a for loop, and what we want to do is want to calculate the total score in each section for 12 sections. So suppose I have 12 sections, okay, and in this 12 section I want to calculate the total score. I have students, I want to calculate the total score of all students in each section. Okay, what do I have to do? I do the same program that I did before. I say enclose the data dash, and I hash define the Sentinel to be -9, and then I hash define the number of sections to 12. Okay, so I have two constant number over here, the Sentinel value, which is -99, and I added over here a number of sections as 12. Okay, and in my program I declare in sections the scores and sum. So I have section scores and sum. So this is I'm going to be using to count how many sections I have finished. The score I'm going to be taking from the user to put the score into the sum, and the sum is the value where I am actually going to store all the grades. Okay, so I'm going to sum them up. And I actually ask the user over here, printf sum scores for each section. And I say for section equals to 1, so this is the initialization. So I have my variable over here, section now. Now this is 1. And then over here I have the condition section less than or equal to number of section and plus section. Okay. And then I have sum is equal to 0, so I have a variable called sum, and I'm going to put 0 in it. Okay. Then I have another for loop, and I'm asking the user to actually do the scores. Okay, actually read the score from the user, and if the score is not equal to Sentinel, I want you to perform this, and the increment is the scanf again. So this code, actually the blue code over here, is exactly the same code as the red code over here that I explained earlier, which is exactly the same as the while loop, which I explained in details in the slide before that. Okay, so this while loop is equivalent to this for loop, which is equivalent to the inner for loop over here of the for that you can see in blue. Okay, so I have the scores. Okay, so I'm going to start. Section is 1 and the sum became a 0. Then I ask the user to enter the first score. So suppose the user enters 1. Okay, I'm gonna check if this is equal to -99, if your Sentinel value is -99. No, so I'm gonna go add it to the sum is equal to sum plus score, so I'm gonna take that value, this will become 1. And then I'm gonna go and ask the user to do another scanf, so I'm gonna read another number. So suppose the user enters a number 2, for example, over here. So what I'm gonna do over here is 2 is less than or equal to Sentinel, is not equal to Sentinel, as that's true, so I'm gonna add the 2 over here, so I'm gonna 2 to 1, this will become 3. Okay, then I'm going to ask the user, he's going to enter a 3 for whatever number he's going to enter until he enters a -99. So I'm going to be adding the numbers all together. Okay, when he enters a -99, this condition will become false. Is score not equal to Sentinel? I'm going to go out and I'm going to print the section, which is 1, the sum, whatever the value of the sum is. I'm going to print it to section 1. This is the sum of it. Then I come to the end of the first for loop. So I go back here and I do increment section. So section is going to become 2 now. Now what I'm going to do, I'm going to say sum is equal to 0, so I'm going to initialize 0, and then I'm going to over here come and ask the user to enter another score. So the user is going to enter for me a score over here, for example, 100. Okay, so this is a very good student who got 100, so I'm going to add the sum to the score, so this will become 100. Then the next student is 1, I'm going to this become 101. Then the next student is 2, it's going to become 103, and so on. I'm going to go until the user enters a minus 99. When he enters the minus 99, I'm going to be having a sum with it, and come over here and this is going to false. So I'm going to say section number 2 and the sum. I'm going to print the sum over here. Okay, so the sum that was here and the sum that was here is going to be printed with section number 2. So the section number 1 actually will be printed with this guy. The section number 2 will be actually printed with this guy. And in the same manner, I'm going to go section number 3, 4, 5, 6 until this condition is false, until 12. So when I have more than 12, it will become 13 because I'm incrementing sections. Then it will be basically this condition will become false, and I jump out of my for loop, and that will end mark the end of my program because I have a return 0 over here. Okay, so this is what is meant by nested for loops. You see how we're going into the loop inside one loop. So inside one loop we want like this, then we finish this loop, we come out, increment it by 1, and then we went to a loop in which we did all this, and then come back 3 and we do another loop, and going on and on and on. Okay, so here is a very good example. Okay, illustrates a pair of nested loops. We have our directives, and then we have int main void, and this is our main function. Inside it we define an I, we define a j. Okay, then we say print I and j. Okay, so we calculate the spaces over here so that the spaces will be like this, and then the spaces like this. That is why we have the spaces over here. So now currently, and just for the sake of example, the output until this line, until this printf, I'll print this out. Okay, then I say for I equals to 1, I less than for I plus plus. So I have two variables, I and I have j. Now I is equal to 1, I put I equal to 1. Is I less than 4? Yes, it's correct. I is less than 4. I'm going to print outer and percentage 6d and I. So I'm going to be printing outer, and I'm going to be printing the value of I, which is 1. Okay, so I printed the value of I to be 1, and this is the outer loop. Why? Because the I is in the outer loop. And then I start for j equals to 0, so j is going to become 0. Is j less than I? Is 0 less than I? Yes, that is true. You print inner, and you print the value of j, so inner is 0. Okay, so I'm printing the value of I in the first one and the value of j in the second one. I represents the outer loop, j represents the inner loop. I'm only going to print the j when I'm in the inner loop, and I'm only going to print the I when I'm in the outer loop. So then what happens after I finish this statement? I reach the end of the for loop. I go increment j by 1, j will become 2. Now since j became 2, is j less than I? That is not true. 2 is not less than 1. Oh, sorry, this will become 1. So 1 is not less than 1. Then that is false. So you jump out of your for loop and you find yourself at the end of the first for loop. So you go increment I by 1. So I becomes a 2. Okay, is 2 less than 4? Yes. So you're going to go print outer, and you're going to print 2. So you're going to print outer 2. Then you're going to come in the for loop, and then j will become, you'll take the value out, it will become 0 because j is equal to 0. You do an assignment over here. Is j less than 1? Yeah, less than I, sorry. Is 0 less than I? Yes, 0 is less than 2. So I'm going to be printing inner, and I'm going to be printing the value of j, which is 0. After I do that, I finish my for loop over here. I come and increment j by 1, it will become 1. Now, is 1 less than I? Is 1 less than I? Yes, it is. 1 is less than 2. So I'm going to go to the inner and print another inner, and then I'm going to print a 1. Okay, so the value of j. So I'm printing over here j, so I'm going to be printing 1. Then I finish my for loop, so I increment j by 1, it becomes 2. Is 2 less than I? Is 2 less than 2? No, that is false. So I jump out of my for loop, and I come over here and I find myself at the end of the outer loop that I have, and I jump back over here to increment I by 1. So I now will become 3. Correct? Now, when I became 3, I am going to go inside the test condition and say, is 3 less than 4? Yes, I'm going to be printing outer and the value of I. So I'm going to be printing outer and the value of I. So it's going to print 3. And then I'm going to go inside the J loop and I'm going to assign the J to be 0. So this is going to go, this has become 0. And then I'm going to print inner 0. Then I'm going to increment J by 1 and print inner 1. Then I'm going to increment J by 1 is inner 2. Then I'm going to increment J by 1. So 0, 1, 2. It's going to become 3. Is 3 less than I? No, 3 is not less than 3. So I go out of here, jump from the for loop. I go here and I find myself at the end of the for loop of the I. And I go increment my I by 1. So I is going to become 4. Is 4 less than 4? That is becomes a false. So I jump out of the for loop and I come over here and that's a return 0. So this is the output that I get from my program. Okay, so you see how we actually went the inner for loop. Since it's linked to an I and a J, my J will never be more than the I. So if my I is 1, this will become 0. If my I is 2, this is 0, 1. If my I is 3, is 0, 1, 2. Okay, and this is how basically the program is going. Okay, so get used to the for loops together each other and try to understand how it goes. Work on the compiler and try to understand what the compiler is basically doing. So this is just the basic that we're giving you. There are lots of tricks and things in it that you just have to sit with the compiler and try it and look at the different conditions that you can actually do. Okay, now we'll introduce you to a do while statement. Okay, for both of the statements, for the for and the while, we evaluate the loop condition before the first execution of the body of the loop. So your program comes running sequentially, and for the while and for the for, you have the condition that is at the beginning and you test that, and if that is true, that is the only time when you enter to the body of the loop. Okay, in most cases this persistence is desirable and prevents the loop from executing when there may be no data items to be processed. Okay, so this is sometimes this is desirable. However, in other situations, this is not desirable, where you actually want the program to go run and then check at the end of the loop if the condition is true or not. Okay, and that's where we actually use a do while statement. Okay. Here's an example. An example over here is we want to convert from miles to kilometers. Okay, this is the first example we actually started from, and in this example, we want to convert from miles to kilometers, and we define the kilometers per mile as a constant, and we say double kilometers and miles. So we declare two variables, kilometers and miles, and we declare a character as res. Okay, to get a response from a user. Okay, and here's what we do. We say do, and between two brackets we put all the statements that we want to repeat, and afterward we put a while, and between brackets the condition in which if this is true we go back and do the do, if not we go out and continue our program. Okay, so this is how the program goes. It goes line by line over here. It conducts all of these, then in the do it conducts this and then tests the statement. Okay, now if I may go back over here, I just like to explain a difference. Okay, so for the for and for the while, for and while, the loop, your program comes over here, there's a condition. Okay, so there's start of condition and end of condition. It actually goes this way. So it checks the condition. If the condition is false, it gets out. Okay, so these are the condition and the end of the curly brackets. So you check the condition. For the do while, you have your program coming this way. Your do while starts here and the while is here. Okay, so I'm going to say here the condition, and here's the condition. In the do while, the condition is at the bottom, and the for and the while, the condition on the top. So your program actually loops this way. When the condition becomes false, you get out. Over here, when the condition becomes false, it's on the top. So you don't enter over here until the condition is true, whereas over here, the first time you enter, the condition might be false, and you will enter to the loop and do it. Okay, so this is a visual representation of the difference between the for and the while with the do while loop. Okay, so let's come back to our example. We have kilometers and miles. We define them too as constant, and we define a character as res. This is a character. Okay, and what we were trying to do in res is we ask the user to input a y or an n. If he inputs a y, that means he wants to continue a program. If he inputs an n, it means he wants to stop the program. Okay, and we actually in the do while we do and between the two curly brackets we put all the statements that we want to conduct. So the program is going to run over here, come inside the do, conduct this, then check the while statement. If this is true, go back to the do this, check the statement of the condition here, the test over here. If this is true, it's going to go back over here and it's going to keep on looping until this condition becomes false. It's going to go out and it's going to continue your program normally. Okay, so let's go in this program. Let's see. You're going to enter the distance in miles and you're going to read the miles from the user. Then the user is going to input a number, for example 5, okay, or 10, for example 10. You're going to calculate the kilometers. You're going to multiply this constant by the miles and save into kilometers, and then you're going to print the value of kilometers to the user. Okay, then you ask the user, do you wish to try again, and give him between brackets y/n for yes/no. Okay, then you say get character. This is for actually skipping the new line character, which is into the buffer, and you actually read a character from the user. Okay, so you read a character from the user, and when you read this character from the user is either going to yes or no, and you say while res, so the value that you have read is a capital Y or a small y. Okay, this value is equivalent, so double equal to and double equal to sign. If these two values have been entered by the user, that means he wants to repeat again. So you go over here back and you do this again, and then you enter ask him for miles and you convert the miles to kilometers and display that to the user. Then you ask him, do you want to continue? Okay, then you get a character. I'm going to explain the get car in a second, just let me finish this. And then you actually scan another input from the user, and then if he enter user's a Y, you go ahead and you ask him to enter miles and then do it, and you keep on doing it until he's putting a capital Y or a small y. When he enters anything that is not a capital Y or a small y, which is equivalent to a no, this condition will become false, so when you'll jump out over here. So you'll do this and you'll jump out over here. Why do we use the do while? Because in this program you have to, when you run the program, you know that the user is going to at least have one number to convert from miles to kilometers. Okay, otherwise he would not have run the program. Okay, so that is why we use the do while, because we don't have to check the condition at the beginning. We will check the condition at the end. We do the calculation for him once, and then we tell him, do you want more? If you want more, I'll go back and do it. If you don't want, I'm going to go out. Okay, now comes the get car thing. Okay, so actually what we have told you till now is that the scanf actually gets the input from the user is not entirely correct. Okay, so what actually happens is so this is your program memory that is in the RAM. So this is your main memory. This is the main function that you're working in, and you have all your variables over here. We told you whenever you do a scanf, you're actually going to the user and taking an input from a keyboard. Okay, so the keyboard lies over here somewhere. Okay, so this is the keyboard, and the scanf actually reads any input that comes from a keyboard. Okay, we actually did not tell you the entire story. The operating system, Windows or Linux or whatever operating system that you're using, is sitting over here, and I'll denote to it to an OS. It's also inside the RAM. And what does the operating system do? It abstracts the hardware from you. How does it abstract the keyboard? It actually allows a buffer. Okay, it allocates a memory, and whatever the user types into the keyboard, it places over here. And when you do a scanf, you actually read from this memory and copy to the memory that you have in your main. Okay, so suppose that the user you start run the program for the first time, you ask scanf and ask the user to enter the distance in miles. Suppose the user enters a 10. So if he presses 1 0, so when the user enters, he's going to press 1, then he's going to press 0, and then he's going to press enter. So he actually inputted 3 keys. He inputted 1 0 and then enter, which I will be using the /n character to represent the enter. Okay, so that is what's stored into the buffer. When you do a scanf over here, %lf and miles, you go and read the buffer. So you will read the 10, okay, or whatever number that the user has entered, and this will be copied from here to the main memory to the variable miles. So I'll have miles, and I'm going to copy the 10 to it. So I'm going to delete the 10 from here and put it over here. Okay, but I do not read the /n, which was the enter that you have put. Now you define a character, and when you define a character, you actually, which is res, and you ask the user to enter a value. So the user is going to enter a value, and suppose he enters a capital S or capital Y. Okay, so he enters a Y, so the Y will be stored into the buffer. Now if you read the buffer, the thing that you're gonna get is the first character is the /n, okay, or the enter that the user has inputted. And after the y, there will be another /n that the user has entered because he entered y and then enter. So to get rid of this /n, you're using a get character. So get character is gonna get this, and then ask it to give it to the main program. The main program is not going to store it anywhere in any variable because it's not assigned to any variable. So you're going to delete this from the memory, then you get the y, and you can continue from there. Okay, so this is why the gets character is over here. Okay, usually what people usually do is do the flush stdin. Okay, so if you do an flush, I think there's a double quote over here also. So if you do the flush stdin, you actually you can replace this get character with flush, and in this what you tell the compiler is to ask the operating system to flush its buffer. Okay, so flushing the buffer means go zero it out, clear it out for me, so anything in it delete it and make a new buffer for me. So the operating system is going to delete anything in it and you get rid of the /n, and then when the user enters something, he enters into a new buffer, and then you can actually get rid of this problem. So this is a better way of actually treating this problem. Okay, now here's another example of a do-while loop, and in this we want to calculate the minimum and maximum numbers. Okay, so let's start our int main. We define our variable minimum and maximum. What we were aiming to do is we want the user to enter a period for us, and for there we have the minimum and we have the maximum. Okay, now the user is going to enter for me a minimum and he's going to enter for me a maximum. So I define n minimum and maximum, and in a value, and we'll use it later on. Okay, we're going to check if the input that the user has input is a valid input or not. For an input to be valid, the minimum should be less than the maximum. If the user enters the opposite thing, if he enters a higher value in the minimum and lower value in the maximum, that means the user has inputted the wrong data. Okay, that is why we'd use a do-while loop. In the do-while loop, we ask the user to enter the minimum and maximum values, and then we read two values and store them in the minimum and in the maximum values variables. Okay, then we check if the minimum is greater than the maximum. That means that the user has made a mistake. So we say wrong input. We ask you to enter the minimum and the maximum. We did not ask you to enter the maximum and the minimum. So I tell him it's wrong input, and I say while the minimum is greater than the maximum. So what's going to happen over here? This condition is going to become true, and it's going to go back to the do loop and try it again. So you're going to ask him to enter the minimum and maximum value again, and you're going to read two numbers from him, and then you're going to check, did he actually enter a minimum which is less than the maximum? If not, you're going to say sorry again, wrong input, and this condition is not true. Sorry, this condition is true, the minimum is greater than the maximum, so I'm going to go back over here, and I'm going to keep asking the user to enter numbers until he enters a number that is less or equal to the max. So this condition becomes false. So as soon as the user enters a number that is the minimum is less than the maximum, this condition has become false, so I continue my program. Okay, now continuing this program, the second thing I want to do in this, I'm going to ask the user to enter a number that is between the minimum and maximum. Okay, so to do that, and to do that, I'm going to have another do-while loop, and I'm going to ask the user to enter a number that is between the minimum and the maximum inclusive. So it has to be between the minimum and maximum. And then I'm going to actually read a number from the user. So if the user enters a number that is over here or here, for example, which is outside the minimum and maximum, I have to tell the user, sorry, wrong input. So I say if the in value, so I read the number that I read from the user in value and say in value, is it less than the minimum or in value greater than the maximum? You say, sorry, wrong input, try again. Okay, so this is wrong. This cannot be true. You have to input a number that is within your period. Okay, and then say, well, in value less than minimum or in value greater than maximum, return to the do while and ask him to enter another number. And then the user is going to enter another number. You're going to check if it's between the minimum and maximum. If it's not, you're going to print this, and then you're going to check this condition is going to be true. You're going to come back again, and then you're going to loop on over here until the user enters a number which is between the maximum and the minimum. So suppose he enters this number. If he enters this number, this condition is going to become false, and you get out and you say, oh, I checked all your inputs successfully. Okay, so this is another example of the do while loop, okay, and how you actually use them. Okay, they're very useful loops. Sometimes they are called repeat until, but in C they're called do whiles. Okay, now we talk about the break statement, and the continue statement. So first of all, the break. The break statement causes immediate exit from the while loop, for loop, do while loop, or switch statement. Okay, so whenever you hit a break statement, you just get out of the loop. Okay, the program execution continues with the first statement after the structure. Okay, so if you are in a while structure and you hit a break, you go out of the while structure. If you are in a for loop, you hit a break, you go out of the for loop. Okay, and the same way with the do while and the switch. Common uses of the break statement is escape early from a loop and skip the remaining of the switch statement. This is why they are actually used. Okay, I have an example on the next slide, so I'm gonna explain the continue first, and then I'm gonna talk about the next slide and the example. What does the continue do? The continue skips the remaining statements in the body of a while, for, or do while statement. So if you put continue inside the for or a while, you will not continue at the end until as soon as you hit the continue, you go back to the condition or the initialization and update, depending on if there's a while or for, and you're going to be starting from there again. And if you hit another continue, you're going to go back. If you don't hit a continue at the end of this structure, you're going to go back and check the conditions. Okay, so this is where this continue comes into place. Okay, while and do while loop continue test is evaluated immediately after the continue statement is executed. So in the while and do while, the condition, so okay, the loop test, the condition or the test is evaluated immediately after the continue. So in the continue, you go back to the test, and you test and you go back in. And if you have another continue, you go back to the test and you test it and you go in. In the for, it's different. In the for, you do an increment first, that's one step, and then you go to the loop test 2. Okay, so in the while loop, you go back to the test directly. In the for loop, you increment, then you go to the loop condition. Okay, so here is an example. I'm gonna hide the output for you. Now in this example, let's suppose I have a for I equals to 0, I less than 5, I plus plus. Then I put sum equals to 0 for j equals to 0, j less than 7, j plus plus. And then I inside here I say if j modulus 2 is equal to 0 or j modulus 3 equals to 0, continue, printf I is equal to and the value of I, then j is equal to the value of j, and then the sum plus equals to I multiplied by j, and then I continue my program for loops, and then I print the sum at the end of the for loops, and if the sum is greater than 10, I break. Okay, so this is my code. So let's start looking at how would this actually occur in our program. So in this time, I'm going to write the variables over here. So I is equal to 0. In this case, when I start the for loop, I is equal to 0. Is I less than 5? Is 0 less than 5? Yes. I'm going to put sum is equal to 0. Then I'm going to come over here, I'm going to find a for, and I'm going to define a j over here is equal to 0. Is 0 less than 7? Yes, so I'm going to go inside. Is j modulus 2? What is 0 modulus 2 is 0. Is j modulus 2 is equal to 0? Yes, 0 is equal to 0. 0 modulus 2 is 0. 0 is equal to 0. This condition becomes true. I have an or. I don't care about the second or because this is true. So I'm going to go inside the if, and that means a continue. When I have a continue, what do I have to do? I have to go back to the loop that I am in. I am in the inner loop, the j loop. So the continue go back to the j loop, and then I increment my j by 1. So this will become 1. Correct, was 0, it will become 1. And then what's going to happen? I'm going to go back into my for loop, and I'm going to say, is j modulus 2 equals to 0? Is 1 modulus 2? What is 1 modulus 2 is 1? Is it equal to 0? No, that is not true. Or j modulus 3 is equal to 0? No, 1 modulus 3 is 1. It's not equal to 0. That means that this condition did not occur. These are not true, so it's false. So I jump over and I say print I is equal to, and I print the value of I 0, and j is equal to, and I print the value of j 1. So I print I is equal to 0 and j is equal to 1. Then I come over here, sum plus equals to I multiplied by j. So I multiplied by j is 0 multiplied by 1, and you add that to sum, so the sum will become 0. So 0 will become 0 again. Okay. Then I finish the for loop of the j, so I go back, increment my j by 1. So I increment my j by 1, it becomes 2. I come over here, and then I look at j modulus 2 is equal to 0, or j modulus, so this is true, so 2 modulus 2 is 0, so this becomes true, so you continue, so you go over here, then j will become 3. So since I hit continue, I'll go back to the for loop directly, do the increment, and then check. Is 3 less than 7? Yes, I come over here. Is this condition true? J modulus 3, so 3 modulus 3 is 0, this is equal to 0, this is true, so I go continue over here, I jump back over here, so 3 becomes a 4. Is 4 less than 7? Yes, 4 is less than 7, so I'm going to come over here. Is 4 modulus 2 equal to 0? Yes, 4 modulus 2 is equal to 0, so I do a continue, I jump over here, so this becomes 5. So now 5. Is 5 modulus 2 equals to 0? No. Is 5 modulus 3 equal to 0? That's no. So I jump out of the if statement, I don't go inside, and I print I is equal to 0, j is equal to 5. So I print I is equal to 0, j equals to 5, and then I say sum is equal to I multiplied by j, so I multiply 0 by 5, that's 0, and then update this 0 with a 0 in the sum. Okay, then I finish this, I go back over here, I increment this to be a 6. When I do this as 6, this condition 6 modulus 3 becomes a 0. Then I continue, so I go over here in 7. When I come over here in 7, is 7 less than 7? No, so I jump out of my for loop. Okay, I jump out of the for loop of the j, and I do print %d the sum. So I'm going to be printing the sum which has the value 0 in it. Then I check, is sum greater than 10? No, it is not greater than 10. So I'm going to jump out of the if loop, and I find the end of the for loop of the I. So I go increment my I by 1. So this will become 1. Then I start again. Sum is equal to 0, so this will become 0 again. And I say for j is equal to 0, so this is going to go, and this will become 0 again. And I say if 0 modulus 2 is equal to 0, yes. I go to continue, I go back, jump over here, j plus plus. That means that j will become 1. Is 1 less than 7? Yes, I come over here. Is this condition true? No, both of these conditions are not true, so I jump over here and I print I is equal to 1, j is equal to 1, and this is what I print over here, I equal to 1, j equal to 1. Then the sum is equal to I multiplied by j, so you multiply I by j, that's 1, and you add it to the sum, so this becomes a 1. Okay, so the sum equals to 1. Then I come back over here in the for loop and increment j by 1, becomes 2. 2, this condition is not true, I have a continue, I go over here, it becomes a 3. 3, this condition is true, I have continue, I go over here, it becomes a 4. And 4, this condition is true, it becomes a 5. 5, I come over here and I actually print I is 1 and j is 5, and then I multiply 1 by 5. So 5 plus 5 multiplied by 1 is 5 plus 1, this will become a 6. Okay, then I end my for loop, I go back, increment 6, this condition will become true, so this will continue, and then will become 7. So I get out of my for loop, and I print the sum, which is 6. Okay, so this is 6 the sum. I print out the sum to equal to be 6 for the user. Okay, then I do check, is the sum is greater than 10? No, the sum is not greater than 10. So I come over here at the end of the ith loop, I go increment my I by 1, that becomes 2. And then I come into the j, the sum then becomes 0, so this is sum is equal to 0, j is equal to 0. I come over here. Okay, now notice from the previous one, we started to know in this condition we're going to enter it whenever we have 0, 2, 3, 4. Okay, so 0, 2, 3, 4, I'm going to skip. I'm only going to print when I have a j of actually I have a j of 1 and 5. Okay, so when I have j equals to 1 and 5, I'm going to be printing this, otherwise I'm just going to be continuing. I can do it for you manually. If j is %2 equal to 0, this is 0, so it's going to go to continue and go over here, and this will become 1. And after it becomes 1, I'm going to come over here, and then I'm going to print I is equal to 2, so this I equals to 2, and j is equal to 1, and then I'm going to multiply 1 by 2 and add it to this, so this will become, sum will become 2, correct? Then I'm going to go on to go 2, I'm going to have this true, so continue. Then I'm going to go 3, this is true, I'm going to continue. Then I'm going to go over here. 4, this is true, so I'm going to continue and go 5. Then in 5, this is not true, so I'm going to come over here and I say, okay, I'm going to print I is equal to 2, j is equal to 5. Okay, so 2 and 5, I'm going to print it out. And then I'm going to calculate the sum, which is 2 multiplied by 5 is 10. I'm going to add to it whatever it was over here, so this becomes 12. Okay, so I come back over here and go back and increment my j 6. This is true, so then that becomes 7. The condition becomes false, so I go out and I print the sum. The sum is 12. Then I say if sum is greater than 10. Is 12 greater than 10? Yes. Break. Break means get out of the loop that I am in. I am in the ith loop, so I'm going to go out and I'm going to go continue my program over here. And that is the entire output that I have. Okay. Now in programs just like this in the exam, and whenever you have something, you just have to be smart enough. When you have a loop that is this congested, you basically look at the logic. Look at the logic. If you have remainder of 2 is equal to 0, remainder of 3 is equal to 0, from the first loop you knew when you did the first loop that you're going to enter in 1 and 5, okay, and that's all the numbers that you're going to enter. So whenever you are inside this for loop, you're just going to go conduct these statements when you are in 1 and 5. So this statement is basically incrementing your numbers and making you go to 1 to 5. So in the next loop and in the third loop, you can actually calculate the sum pretty easily. You're only going to go on 1 and 5, so you have to multiply 1 by the value of I. So if the first time we have the value of I to be 0, 1 and 5, and the second time we have the value of I 1, 1 and 5. This the third time we have the value of I 2 and 1 and 5. And you can multiply these two values, I and j, and add them together to know what is the sum. So 1 by 1, 1 by 5, that's 6. So 0 by 1, 0 by 5, that's 0. 2 by 1, that's 2. 2 by 5, that's 10. Add them two together, 12. So you get the value of 12. Okay. So this is how you do it, and you have to be fast in the exam to do it because you won't have much of a time to actually do the entire loops again and again. So try to be fast and understand how the continue and breaks are arranged to get a logic out of it, and use that logic to solve your questions very fast. Okay. And with this, we come to the end of our 7th lecture. I hope you enjoyed it and hope to see you again in the next lecture. Bye bye.